Hi everyone. Good evening, whatever time you're joining us from. I hope you had a good day. Okay. So my name is Chinonso Okonkwo and I am a Better Microsoft Learn Student Ambassador. And today I will be handling this workshop on SQL for Business Insights. So basically, I will be taking you through writing queries. I believe that the best way to learn is by doing. It's not only by taking courses, you also have to practice and work on it. So what I'm going to do right now is I'm going to give it 3 minutes for others to join us because some person signed up for this class and I'm guessing maybe they are running through um, some unforeseen circumstances. So we just give them 3 minutes to join us so they don't miss out on anything. And then we'll start the class. Now, like I said, this is the SQL for Business Insights class. And once again, my name is Chinonso Okonkwo. All right. So some of the prerequisites you're going to need is you need to have Microsoft SQL Server installed in your system. So it's not just about taking a class. You need to have it installed on your system so that you can go back and work on it. It will also be good if you have experience working with data in a tabular format. So if you're coming from an Excel background or you're even coming from any background, say high school or secondary school, where you've worked with data in rows and columns, that is going to come in helpful for you. So one thing I like to do before any course is I like to go through what I will be teaching for this class. So we're going to start with an introduction to SQL. We'll talk about what Transact SQL is. Then I'll move to basic SQL. Then we'll so to start with, and you can also call it SQL. It stands for Structured Query Language. Now, SQL is a query or declarative language that is used to communicate with databases. Common databases like Microsoft SQL Server, PostgreSQL, all of these are common SQL databases. Now, let me take it back. What do I mean by SQL is a query language? Just like the name means query, it is used to ask for results from your database as well. So you're basically querying a database to fetch you some data that you want to use. Also, SQL has been argued about, is it just a query language or is SQL a programming language as well? Now, SQL is, when you talk about programming languages now, you know, you have procedural and declarative under the categories. Now, SQL is a declarative programming language in the sense that you basically just declare to the database what you want it to fetch for you. You're like, select from this. You're not exactly telling it how to go about the order of execution. You're just telling it to do this for you and to fetch you back the results. So that's why SQL is called a query language and a declarative language as well. Now, when we talk about the different database management systems that we have, where we mentioned Microsoft SQL Server, MySQL, it makes you wonder that do you need to learn all of this server? Do you need to learn all of this? Do you need to go ahead and be like, okay, I'm learning SQL Server, I'm learning MySQL. All of these are basically just variations of the standard SQL language. So these organizations, they each set up their own variation of SQL, adding other functionalities to it. For instance, now, when it comes to Microsoft, their variation of SQL is what we call the Transact SQL or T-SQL for short. Now, Transact SQL is just like another dialect of SQL per se. It's just like when you have English, there is the American English, there is the British English. So Transact SQL is just a variation or a dialect of SQL. So you don't need to learn all the you don't need to be bothered thinking, oh, if I know how to use SQL Server, how do I work in MySQL? You can apply the knowledge you've gained from working on one on the other. So basically you can apply what you've learned from this one to the other one because some of the syntax do not change. But the only thing you notice is slight variations. For instance, now in PostgreSQL, when it comes to a certain syntax, you use the limit when you want to limit the number of data you want to get. But when it comes to Microsoft SQL Server, you end up using top because you just want to get top number of rows of that data. So that is just, there are like some slight variations, but if you're good in Microsoft SQL Server, you can apply the knowledge to any other database system, depending on where you work and what tool they use. Now, talking about SQL Server, talking about SQL and bringing up relational databases, what exactly is a relational database to start with? So a relational database consists of series of tables that are connected by unique IDs. For instance, you can see the customer ID over here, which is connected to the sales order header table with this ID. So in this table, the customer ID is the primary key, as you can see, while over here it is the foreign key. So a relational database is composed of different tables with their unique connections or unique IDs to establish relationship between them. Now, you might be wondering at this stage that why do we even need SQL and why is SQL coming up in place here? As a business, when you start working and your business starts growing, you end up generating tons and tons of data, which you should do exactly as your business is growing, right? And to get access to this data and to process this large amount of data even faster, you'd want to store your data in a database so you can just retrieve what you need at a specific time. So businesses store their data in a database, and you come in there as a SQL developer or as a data analyst or as a data engineer sometimes to help them query that database and to get their data from the database. Moving on, SQL statements are basically grouped into 3 types, but I will be focusing on data manipulation language, more so on even data query languages. It includes statements like we have the select, and also we have some modification statements such as insert, update, and delete. So in this data manipulation language now, it is split into like data modification language and of course data query language. So this means I will be focusing on just the data query language in this course. So what you can do with your data, which is selecting from your data and making aggregations from your data, writing subqueries from your data, which is like the typical role a data analyst would go through. You would be doing less of updating any data, if even any. But what you'll be asked to do or tasked with is majorly querying your databases to get certain data for you or for your stakeholders rather. Now, moving forward, let's talk about, let me first introduce you to some basic syntax that you would deal with when you write SQL code. So I want to like give you the syntax, like a brief overview of this syntax to start with, right? So you have your select, you have from, where, group by, having, and order by. So these are the SQL statements or SQL syntax that you use majority of the times, like majority of the times, right? And I've placed beside this some mnemonics to help you remember it, which is some French waiters grow healthy oranges. Now, why am I showing you all of this right now, just the way it is ordered? Because in SQL, the order of execution is important. The way it is, the way you order your queries is actually very, very important. It has to come from select, from, where, group by, having, order by. So in all queries you write, sometimes you might not necessarily have a whereby clause in every of your query, but when you do, you need to know it's coming before a group by. A whereby clause, this where cannot come after a group by. You would run into an error. You need to structure it in this format: select, from, where, group by, having, and order by. You don't necessarily need to cram the syntax or anything, but as you write more and more SQL queries, you would get used to them. So let's move on to I just want to show you what it looks like when you write a first basic SQL query. So There is this database which is called the AdventureWorks. So AdventureWorks is a business, and this is the database of the business, AdventureWorks. So how do you select data from this database? You're asked to generate a list of all the orders that AdventureWorks have received. How do you go about this? So this is just your very basic introduction to SQL. What you use is select statements because you are trying to select data, right? And now you see this asterisk here, or the star. This star stands for everything. It's basically saying all the columns in that table is what you want. But if they specify that they don't want all the columns, I want you to just pick this column and this column. Let's say it's column first name and last name. You have to write select first name, use a comma, then your last name. But if they ask you for all the columns, it's way easier to just use a star than to start writing down every column name. Then we move on to the from statement, which is from adventureworks.saleslt.sales order detail. Now, what does this mean? What does all of this stand for, right? Your AdventureWorks stands for your database. So your AdventureWorks is the database name, while your sales LT is your schema, or your schema name rather. And finally, your sales order detail is your table name. So you might know what a table is, which is just a combination of rows and columns, right? And a database is where you store millions of rows of data that you cannot store physically, like maybe in a spreadsheet. Now, what exactly is your schema, you might be wondering? So a schema, for instance, now is an organization of your data. Let me give you an instance now. You have, in the ideal sense, or when you start working out, you might access databases that are so, they have so many tables of data. Now, how do you even start to make sense of those data? This is where they create an organization of that data, which is a schema. So what do I mean, for instance, now? Let's say you have information about sales, right? And you've decided to split this information about sales into different tables. Now, let me tell you, why are you even splitting information into different tables? Why are you doing all of that? Well, it's because you want your performance to be faster. You want, when you query this database, it returns as fast as it can. So that's the first reason why. But now let's go back to our scenario, right? You have sales data that's been split into different tables, right? You have sales data which contains about the salesperson who actually made these sales. You have sales data which contains about the sales that were actually done, like the quantity. You have sales data which is about the location, perhaps the location of the customer that purchased from you. So all of these are in different tables, right? But all of these, you can organize it into a certain grouping, which you place under a schema. So in the sense that if you are trying to access sales or production information, if production is another schema, you can just do that. And this is where I'll show you a schema of one of the AdventureWorks database. So I'm just going to open a schema for you so you can see, rather I'm opening a diagram, an entity relationship diagram, so you can see what a schema is. So if you look at this diagram at first, you are overwhelmed. You have so many tables everywhere. You don't even know where to make start from. Even at the beginning, you're like, how am I going to go to all of this? Where do I start saying, okay, where do I need to they've given me query. My boss has given me query to write these codes, extract this information. Where do I now start focusing on? So if you notice something now, if you look on your left-hand side, you see schemas. You see sales, you see purchasing, person, production. So these are schemas. And if you look over here, you see that they have been segregated using color coding. So once you look at these sales, which I know you might not be able to see clearly, but in this sales schema, you see related information about sales. So it's just organized together in a format that if you're trying to perhaps just go through a sales analysis, you just want to get some revenue numbers or something, you can just go directly to the sales schema and just focus all your analytic efforts in there. So it makes it easier. Now, I don't want you to get overwhelmed with this. As we start with, I believe like SQL is something that I said that is difficult to learn, or like you get confused sometimes, honestly. Everybody does. But it's best when you start learning SQL, you start learning with like a small database, right? Let's just go back to the slides. And when we want to start writing queries, which will start soon, we are going to make use of an easier or maybe a simpler database per se. Also, before moving on, I would like to mention that in case you have any questions, you can write them down in your notes, you can jot them down, or you can even put them in the chat box with like Q, then the colon, and write your question. And at the end, when we have the Q&A session, I will answer your questions about it. I know some people answered questions when they asked me some questions when they filled the form, so we'll also address that as well. So moving on, I want to talk about something, first of all, which I call nulls. So nulls, to a very simple level to explain this, null is basically an unknown value. So when you see your data in columns in SQL Server, you can see nulls when you have no data there. But it doesn't necessarily mean there is zero data. It's just an entry which is null, representing an unknown value. Now, if you have nulls, how do you deal with them? It's basically like, how do you deal with empty data in a way? So I gave an example here, which I want to explain, using is null. So is null is a syntax that you can also use. Let's start with focusing on what we have right here in this middle section. You have your is null. Into a bracket, you have an expression which you pass it, then a comma, then the results you want it to produce for you. So I'll come again, you have an is null, open parenthesis, then you have an expression you want it to look at, or a column name, and then finally you have a result you want it to produce. Let me explain what this does. So is null is going to check this column middle name, and if indeed it is null, or like there is null in that column, it's going to produce whatever result you put in this quote here. So right now in this quote, I have nothing in it. I don't even have a space in it, because that is what I want. So that is what is going to fetch me. Now, understand, I'll explain to you how we integrated that in this SQL query. Let's break it down. Let's talk about this function to concat. Concat is like short for concatenation. And what concatenation is about joining. It's about joining two or more things together. Now, when you want to join your data in SQL, which is not joining tables of data, by the way, this is joining like columns of data together, right? You either use the concat or you make use of your plus symbol. So you're either using the concat or you're using the plus symbol. So what exactly is this concat doing? First off, it's fetching my first name column and last name. So what I want to do is I have in my rows of data, or in my table of data rather, I have first name, I have middle name and last name, and I want to create another column, which is full name rather. So I want to create another column, which is full name. So how do I go about this? So the concatenate is going to take basically the variables or the columns that you want to join together. So it starts with the first name, which is what I want first, right? Then a comma, then the next thing which I want, which is, I do not want to write concat first name, comma, just last name. If I do that, it's going to merge it together, just like nonso together. without a space in between, which is not really what I'm trying to do. I need a space between it. So that's why the next thing I did, the next expression I fed into this concat was this quote mark with a space in between. So you can check this. There's a space here. There is none here. Then after that, I fed it this result of is no middle name. So some of my middle name columns are no. Some people don't put in the middle name. Some people do not have middle name. So I'm like, if they don't have middle names, just nothing. Just give me their first name and their last name. But if they do, put their middle names for me. That's all I want. And name this new column full name. And where are you getting all of this from? Where are you selecting this from? This is from the table, from sales LT schema, the customer table. So I'm getting the full name of our customers. Now you will notice this semicolon. Now it is advised that as you write your SQL query, you end every SQL query with a semicolon. But you can run some codes in SQL Server and it will run without the need of the semicolon, right? But what I will advise is just stick to it as kind of like best practice, that whenever you write your query, you end it with a semicolon. So moving on, I want to ask this question. So we're going to start with our first quiz today. So I don't know if you've been following, but I can always draw back. I can always repeat what I've said in case I got cut off at any point. So to start with, this question is, you're asked to return the cell phone column from the sales LT, the customer table. Now, for rows where the cell phone value is null, your query should return the text none. Now, what query should you use? Are you going to use option A or B or C? You're asked to return the cell phone column from the sales LT, the customer table. So I'm going to give like a minute or two for you to look at the question, pick your answer or your option, and type it down in the chat. If you're going with A, B, or C. So I think I'm going to check the comments now, or I'll just give it 1 more minute, just 1 minute, then I'll check the chat box to see what you have selected. So just a bit more time. I think that's enough time. We still have a lot to cover. So just going to check. Just take the part. Okay, I can see Stefan answer A, and A is the answer. All right. That's correct. We can go back to continue our presentation. Can go back to continue our presentation. All right. So you're correct. Indeed, the answer is select is null. We are using the is null function to wherever you see relating to the cell phone, return wherever in the cell phone column rather, and you have any null value there, replace it with null. And you still want the column name to be cell phone, right? So now I'm going to explain. This is the last query I'm going to explain here before we go into SQL Server now, start officially writing queries. And why I want to explain this exercise is because of I want to explain the order of execution. Now, if you remember earlier, I said select from, where, group by. I basically gave you the rundown of how you write your code. But we didn't talk about how it is being executed. And you might think it does not matter because, you know, I don't care. At least me, I thought so when I was learning interpret. I was like, I don't care. As long as I'm writing the query is not going to give me an error. I don't care how SQL Server Studio is choosing to run it. As long as they're fetching me my right result. And that's where it comes in. You're going to get an error sometimes, and then you need to know why. So let's answer this exercise together. You're tasked with analyzing the order data in the sales, which is the sales schema, sales order table, to identify the date on which more than one order was shipped. They want to know the date which they shipped more than one order, right? So you have to write a SQL query to select the order date, right? Select the order date, that's number 1. Count the number of orders for each date, that's number 2. Then this condition where, this filtering condition, where the order status is shipped. So this is something you also have to keep in mind. So group the results by the order date and only include those dates with more than one order shipped. We don't care if one order was shipped on a day. We want the days that more than one order was shipped. And then finally, which you get to know as the easy part, is ordering your results in SQL. So finally, order the results by the most recent, which is the latest, to the oldest or earliest order date. Now, let me break it down again. They said the output should include 2 columns, order date and orders, which is the count of shipped orders. Now, the very first thing I try to do when I see a SQL query is to try to understand what is the result they even want in a way, like, or what is the columns of data I'm dealing with, what is the table I'm dealing with. So that's like that's where I start thinking from. That's like my thought process. I think about the columns I need to include in my results. I think about the table where I'm getting it from. In this case, if I'm not joining anything, so I'm not thinking about multiple tables. I'm just thinking about one table. So for this question now, we know our solution must include 2 columns, which is order dates, that will contain different days. And then we should have another column, which is orders, that will contain the number of orders. So let's say I have on the June 21st, 2024, the number of orders I shipped on so date is 4. I should have that as one row. Let's say June 22nd, 2024, number of orders I shipped were 5. I should have that on another row, basically, right? So also, I need to make sure that I'm selecting only the results that has been shipped out already, because there are some orders that have been ordered already, but they have not been shipped out. So I need to make sure the order status is shipped. So when you see where the order status is shipped, or trying to tell you to filter in your results, you know you're going to end up using a where. So a where clause. A where clause is used for filtering. So the very first thing you can start with is, let's move to the next slide. You can start with writing maybe your table name from, you know, the table you are getting it from. So we'll just go direct and type in SQL Server from, we'll type the table. Then the next thing we do is to write where we're selecting our data from. So we put select, we write the columns we want to select, right? So I can write select. I know order date has to be included. And I was asked to do what? Let's go back. I was asked to count the number of orders. So I'm going to use a count function. This is an aggregation. Aggregations are count, sum, min, max, basically something that lets you perform something easier. Like it's kind of like when we talk in Python program, when we talk about aggregations, for instance, it's just like instead for you to go ahead and be writing a code to do a certain action, you just have one syntax that will help you execute it. So yeah, count is that syntax, for instance. So select order date and count. Now, why am I choosing order ID? Now, they told me to count the number of orders. In some cases, this thing might not even be included, order ID, to make it easier for you. But in the orders table, there is always a unique identifier. In every table, it has a unique identifier, something that stands in. Just like you have a serial number, or let's say in schools, you have your unique registration number. That is your unique identifier. No two orders have the same like order ID. So that's why I'm using a count order ID. So I'm counting the number of orders. That is why this is count order ID. And then I want the new column to come as orders. I want it when I see that order date, I will see orders there. Now I've executed the select and the from. The next thing is to include where, like some French waiters. So waiters, so that's W. So our filtering option, which is where. They told us that we have to filter for where the order status is shipped. So once the very first thing you do when you get SQL though is you familiarize yourself with your tables and with your column names, because you would not know that status shipped, you have to use the status column. You don't, you have seen it in that table that you would know and you see it. So you have to use a quotation mark, a single quotation mark, where your status is equal to shipped. Then this is something I must mention. Whenever you do an aggregation function, or whenever you have an aggregate in your select statement, always know you would use a group by function. And you will use a group and write a country. So whenever you use an aggregation function, you need to use a group by. And if you don't, you'd see your query would not run, and then you just remember, what am I missing out on? What did I not do? Oh, a group by statement, then you group by that. The error code might even tell you exactly that in a way. Now, just like a where is used to kind of filter your results, having the next syntax, having, is also used for that as well. But having is used when you have aggregates. You can't use where count order ID is greater than 1 here. You have to use having whenever you have an aggregate here. And now, after this, the next thing they told us was to order by the order date. So we need to order by our order date in descending order, because they said they want what? They want the most recent orders to come first. Now, let me explain something that I thought about initially myself. When I was writing SQL queries, I'll get to this point where I'm writing having count orders greater than 1. And I'll be tempted to just, come from here where I have alias. Okay, I think I forgot to mention this. As orders, as stands as an alias. So it's like when you say you're also known as this thing, you can also refer to me as this. Instead of saying count order ID, you can call me orders. So that is what alias is. It's just like a basic way to rename your column or table names that you want them maybe shorter. Do you get? So this is where as comes into place. Now, let me take you back to what I was saying. When I was writing queries, whenever I got to this having part of the query, I would be tempted to like, okay, count order ID. This is represented with orders here, right? Let me just drag my orders and put it here and do greater than 1. And most of the times it didn't work and I didn't understand why. And this is why I said I wanted to explain this, which is the order of execution, which we're going to move to next. So let's go back. You see, we have select, from, where, group by, having, and order by. But when we move next, you see that this is the order of execution. the order we write our query or we declare our query is not the same order it is executed. And if you notice something here, let me start from the beginning. Let's start from the base. Let's start from. So the very first thing it's going to do is it will find the table. So from which table? Whenever it asks it a query, it starts from finding the table. So from the table, it's going to generate or get, not physically per se, so just get like a virtual table of everything in this sales order table, right? Once it generates that, the next step is going to do is going to filter that table. So it's going to filter it in the sense that if it's shipped, that's only what it wants to see. Then that's filtered that down. The next thing it will do is now aggregate your results by order date. So you end up seeing each value by order date. And then after this, it will further reduce your results based on what you're giving it, which is your filter value for orders that are greater than 1, which is having count order ID greater than 1. So after it has done all of this, it's when it will now select even the data you want it to. So there are still other columns there, but this is when it will now decide, okay, what does this girl say she wants again? Okay, just order date, right? And just count order ID, right? So that's when it's going to produce that to you. Once that is produced, then it will order your results by the column you chose, which is like the order dates now. So this is the order of execution. And now, what you notice in this order of execution is that having this select statement that I aliased as orders did not come before this having. So I can't go ahead to say having orders greater than 1. There is no orders in that table to begin with. I was the one that decided to alias it. So that's why it would not work, because of the order. So once you have this, you can use your orders in order, you can't use your orders rather in this having function. You have to use this. Just copy this and paste that. Let's move back. So this is basically the order of execution of SQL queries. So I'm going to move to the next thing. I think I'm getting some feedback that some persons might not be able to put in their answers in the chat box. And I want you to still note down any questions or any feedback you have in maybe a note or in your phone or any other device. When we get to the Q&A session, I'll find a way to rectify that or to have you unmute your mic so we can have your questions. So moving on. Let's talk about join statements now. I'm just going to roughly go through this. I don't want to waste the time. We need to head off to SQL query, right? So a join statement basically allows you to join the results of 2 tables, right? I think for time, I might want to pause, hold back on this a bit and get us to go to SQL query. So we'll come back to this slide and we'll complete this. But let's start with writing queries in SQL Server. So I sent a link in the mail to download SQL Server, and I will still send that in the follow-up mail as well. But for now, I'm going to open SQL Server. So we're going to open SQL Server Management Studio, which will allow us to write queries. So every resource I'm going to be using in this class, I will share it I'll create a Google Drive and share it, or rather I would upload it to OneDrive and I will send it via mail. So I'm just waiting for SQL Server Studio to open for now. Before that, while that's coming up, I can continue explaining this. Right. I was talking about join statements. Let's see, this doesn't take a while to open, except it's already running in my background. But let me just try it again. Okay. Okay, now that's it's coming up. So while that's coming up, I think I've opened it twice. Okay, while that's coming up, we can, I'm trying to minimize this so you can see my screen, but I can still explain without that. To come up so I can minimize it. Yes. Now I can. Patience will take you far. Okay. So I'm just going to, once you open your SQL Server Studio now, the very first thing you see is this dialog box, right? Now this dialog box shows you your server name. Your server name is basically like your local machine, your system. So this is my desktop, blah, blah, blah. This is it. So once you see this, the very first thing you want to do is just connect. Let me try to close this other tab. So you're just going to connect, click connect, right? So while that is loading, I just want to explain joins, right? So going back to that, a join statement allows you to pull data from more than one table at a time. This is a must in the sense that, like I said earlier, what we aim to achieve is performance. I want it to run faster. So what we do is we split data into different tables. It's called database normalization. So a join now is you trying to pull the data from different tables. For instance, you can have customer data in your customer table, and you can have your sales data in your sales table. So using a join statement will allow you to create a relationship between both tables and get your result. Basically, you might want to see which customer has made the most sales, but you can't get those information solely off each other. You have to join those two tables together. And whenever you're trying to do SQL joins, you have to make use of two statements. You have to use the join statement and the on statement as well. Now, this right here is just a simplified join syntax. So you have from your first table, which you want to join, and then you pick the join type, which we will talk about next, because there are different joins you can decide to do. Then you put your second table. Then the next statement, which is on, and then your join condition. So let's go back to Microsoft SQL Server, and we'll close up a lot of the rest. This is the one that's opened. I will close this one and close the other one as well. Cancel this. I'm just going to do this faster possible. Okay, so we can leave that for now. So once you have connected, this is what you see on your system. You see this this interface. Basically, when you look on your left, you see the object explorer. So underneath this, you can see the different objects, right? You can see your database, which is what you'll be working with. And then if you go directly here, you can see the different tabs you might need, files, maybe open a new file. And finally, you can see where you can generate a new query, which I will just click on right now. So I'm going to generate a new query. So once I click generate a new query, this tab here gets activated. So in this tab here, you can see the available databases you have, right? So let's go to your databases here and just click on this plus icon so you can break it down. Once you break it down, you can see the different databases you have. So initially, once you install SQL Server, you will not have these databases, except you decide to restore them or install them or get them from a file or write a code to insert data to a database. So these are because I have installed them. So the very first thing I want to do is go directly to show you how you can restore the AdventureWorks database into your SQL Server. So this one right here is what we're going to be doing, AdventureWorks 2019. So before I go ahead and restore that, I would right click on that and delete it. Okay, not the name, not the name. No, I want to delete it, not the name. So I would right click and delete this. So once that is done, I'll select OK here. Yes, I want to delete this database. Once that's done, you need to first download the AdventureWorks BAK file. I would either upload the file or the direct link to where you can download it from a GitHub repository, right? But you would get access to that. Now, once you download it, obviously it's going to be in your downloads folder, right? The next thing you want to do is make sure that you put that file in a particular folder. So I'm going to show you where you want to put that file in. So you go to your file manager, you go to local disk, right? Once you're in local disk, you go to program files. This class, I'm going to still share the recording. So in case you need to go back to this site, you would see it. So you go to your program files, and then you just search Microsoft SQL Server, Microsoft SQL Server. Yes, and then you keep following that. MS SQL Server, just follow that. MS SQL, follow that. And then you can paste it here in this window. I mean, you could have Ctrl+C, copy that, and then here you just do a Ctrl+V to paste it like I have here. I have the AdventureWorks 2019 BAK here, but I can go to my backup as well and also put it there. So you can put it in your backup or you can put it, okay, depends on what you want. So once that's done, you have it in that, you need to make sure you do this, right? Once you've done that, you can come back to your SQL Server, right? You can come back to your SQL Server, and then in your databases, you just right click, and yes, you select restore a database. Restore database, that's what you want to do. You want to restore this database that you have stored up. So first off, what is the source of your database? It's on your device, right? So you have to select your device, and then you have to go to the location of that device, right? You have to go to the location of the device. So I'm just going to go to add to get the location, and sometimes it will automatically pick it up for me. But if it doesn't, you can locate it from here. You're in C, which is like C users. You go to program files, then you go down to where you have it here, which is Microsoft SQL Server, MS SQL. You can see it in your backup. But mine has picked it up and it's right here. So I'm just going to select it, right? So yeah, that's selected and you can click OK. So you see that looks okay. So I'm just going to click on OK, and that should work. So now we're just going to click OK and wait for that to run. And you would have your database restored successfully to your system. So once you go in here, let's go back to this point here now. You can now see AdventureWorks 2019. Initially, you know, I deleted it, but now we have it here. So you can now put it back down and you can see your tables, right? So you can see tables, views, several things you might need. So let's go to tables, which is what we'll work with. tables. That's taking a bit of time to expand because this Adventure Works has a lot of tables. If you remember or you recall the ERD diagram I showed you earlier that looked like a lot, then this is the database for it. So as I'm scrolling down, you can see so many tables, so many tables over there. So I just wanted to show you how you can get in with this. But this is not what we'll work with for now because I want to bring you up to speed. But once you have gotten to a level where you feel like you understand SQL queries a bit, you understand what the syntax does and what you expect as results, what kind of joins to use, that's when you can now come and practice working on this. There are lots of things to practice on. Before I digress, now that we've gotten this, we're going to now work with the database I want us to work with, which is the NotWind database. So I'm going to delete this here so I can show you the process of getting that in. So right click, you see your delete, then you delete that. In case you want to go to the process and know you can restore a database or write some queries to update data to a SQL Server. So now that I've deleted that, I've come to databases now if I want to create one. And right click on my databases, then new database. Yes, I want to create a new database. Because what is my database name now? I'll give it any name I want, but I'll stick with my NotWind. But let me just add an S. Okay, let us NotWind. Let's just leave it as NotWind data. And then I'll just click OK. That's fine by me. So instantly it was updated here. Now that I've clicked that, I'm going to open a new file which contains the SQL query I want to run. So this file is also something you would download. I would also drop that in the resources as well. So you go to your file, right? Let's start all over. You go to file, then you go to open, right? What do you want to open? You want to open a new file. And then you go to your this SQL code, which is inst WND. Basically, you would get that, you would download that. So you just need to have that in your system. Then I'm going to open it. So once that's open, you'll see some code. So this is where you see the code that allows you to create basically a data frame. So if you scroll down, you can see there are lots of like insert statements. This is creating like a database. So once I have this now, I will execute this. This is where I'm going to execute. But before I execute, there's something I want you to know, right? You have to make sure that this, which is like your working database, is always selected to be the database you want. So I want to execute this in my NotWind database. So I have to change that. Default is always been master, but you have to change it to what you want, which is my NotWind. Now that has been selected, I can now execute this. So you can see here executing query, and you can see command successfully completed. So now I can go back to my NotWind table and see if, okay, do I have tables in this now? Has this thing worked? So checking your NotWind, checking the tables, expanding the tables. NotWind, yeah. So you can see you have different tables now here with the schema being DBO in this instance. It was just named DBO. So you have categories table, customers, employees, you have different types of this table. Now, after you get your data into like SQL Server that you want to work on for a project, or you've connected to it for work or whatever, what you want to do next is maybe create a database diagram. You want to see the connections between your tables. You want to see the relations between it, because it will also help you when you're writing your joins. So what do? You go to your database diagrams here, right? and you can right click that you want a new database diagram. Do you wish to create them? Yes, I wish to create them. So that's just a no-brainer. So once you get here, you see all your list of tables. So holding your shift key, you can just select using your down arrow to select all, and then you just add all of this. So it's going to add this and show you the connections between the tables. So ideally, if you're working on like a data set for maybe a SQL challenge, they usually give you a database diagram, or you try to create it yourself. You try to like create it yourself to get the relationships, to look at the unique IDs that you can connect to another table. So this is done now, so I can just hit on the close. So this is a very, very large table. It has expanded, so we can't get to see everything at once, but you can see some of the connections here. You can see this arrow connecting this table, customers, with others based on this field, customer ID, customer ID. Now, customers has the customer ID, so this is its unique ID. But for others, this is its foreign ID, while this is like its primary ID here. This is its foreign ID. So I'm going to use my control to try to zoom out a bit. So I'm trying to zoom out. I'm holding control and trying to zoom out a bit so you can see the connections even better. So you can see this, right? So you can go through this. Also, I have downloaded a database diagram, an ARD that can help you understand the relationship. That is much clearer actually. So I'm going to open that. So I'm just going to open that instead. Where is it? The ERD not swing diagram. Right. So if you look at this, you can see that this is basically almost the same thing as the others, but you can see this better. You can see the connections between the tables you have. You have your employees, you have other details, others, you have customers. You can see other details here being connected to others. You can see others here being connected to customers. Basically, you can see the relationship, which should help you when you write, when you're trying to write join statements. So we've covered at least you getting into your SQL Server Studio, the interface. Let's go back to SQL Server. Let's go back there. We've covered the interface. We've covered how you can get data. You can download a file and then execute it and store it in a database, or you can restore a database, like the popular AdventureWorks database, which has been used which you can use to work on diverse projects because it's a large data set. It is very rich. So now we're going to open some exercises to write some queries with this. So what I'm going to do is I'm going to go to my, we can save this as well. So, I showed you a diagram, right? I showed you a diagram already downloaded. So if you've created your own ERD diagram, you can also save it, right? You can save your diagram as well. Like, let me say I want to close this now. Let me just enter a diagram name. Let me call this my Northwind ERD diagram. ERD, just call it ERD, and just close that. I just wanted to close that now. And I'm going to close this query as well that I used to generate the database. So let me just close that too. And I will show you the first way you can write your first query here. You can select, you have the Northwind, right? You can right click on it. Okay, no, just go there. Go to your tables, right? Select a table that you want to explore. Say we want to explore the product. We can right click on that and we see this select top 1000 rows. So we click that and it will generate the query for us automatically and run that and give us our results. So from this now, you can see the query, right? And your results. So this is just like the basic way to start out. This brings me to explain what this is, which is a comment. If you are seeing codes or something, you see that sometimes people comment out lines in their codes so that when they come back to it, they understand what this code is actually doing. So it also serves the same purpose here. You want to comment out what your script does. For instance, now this one is selecting the top N rows, right, from the SQL Server Management Studio, which is SSMS. Now, what can you do? Say I want to like comment out this line of code. Let me see if there's anyone I might say I want to comment out. Let's say unit price. And I can just come over here to this part. You see, when you hover around it, you see comment out the selected lines, and that will not be generated in my query again. Let me run this. Execute. See, we do not have a unit price after a quantity per unit anymore. But what if I want to uncomment that? I can select that and uncomment that. So let's run this quickly and execute this. And of course, you see your unit price there now. So this is just the basic query now. Let me open an exercise. I don't want to save this, so no. You can save your queries yourself, but I'm not saving this one now. I just want to open a new file. So I'll go to file, right? Open, and I'll select the file I want to open. So I'm going to select this exercises file I should have here, and I will just open that. So once I open that, the first thing you see here is use not swing go. So this statement is trying to overrule what happens here. If you can see here now, the database has reverted back to master. So any code I run here, it's always going to use the not swing database to run it. So I will not get an error. So it's either you include this in your statement, use the database name and your semicolon, then go, or you come here and make sure you verify that it's in the not swing, which is the database you're working with. So I've splitted out these exercises into different things. We have the basic SQL queries that I would write. We have the SQL queries for joins, some questions here. We also have SQL queries that makes use of the having function or syntax. And we also have some intermediate queries that will entail us using subqueries and doing some aggregations in this. So we try to see if we can cover some, and if some seems like they can be repeated, we can skip those and move to cover the maybe more technical ones. So we can start now. And the first one is this basic SQL queries. I think I would, before we start these exercises, or I want to see if anybody has any questions that maybe I can clarify before that. So let me just check that. Um, so if you have any question, you can maybe drop that in the chat box now. So before we start the exercises. Okay. Just 1 more minute. If there's nothing, we just move forward with the exercises. I think maybe more questions will come from that side then. All right. So with no questions, we'll continue. Maybe more questions will come along the way or not. So let's go to SQL Server now. So the very first thing we want to do, the first question starts with retrieve all columns from the customers, orders, and suppliers table. So first thing you might want to do is also maybe familiarize yourself with what you're working with, which is your tables, right? So you can see we have our customers table, we have orders, and of course we have suppliers here. So this is a really basic one. Retrieve all columns. All stands for everything, which is, that's why we're going to use an asterisk, which is like our star. That's to retrieve all from which table? From the customers table. So I can just say from, where's my customers table? It's over here. I can just drag that and place that here, right? And then I can select that and execute that result. So this would run and produce all the columns in this table, in the customers table. So the same way you do this for the customers table will be the same way you do this for your orders table and suppliers as well. So obviously we'll do select all from the orders table, which is here, or select all from the suppliers table. So let's move to the next question now. So the next question says, retrieve all customers' detail alphabetically by country and by name. So all customers, you already know it's saying, okay, we want all customers' detail, all customers' detail. So that's select all. Which table are you getting your customers' information from? Your customers table. So from, where's your customers? Some customers, place it over here. And then finally, there is the saying alphabetically by country and name. So what does this tell you? Alphabetically, A to Z, Z to A. This tells you that you need to what? You need to use the order by. So you can order by your country and then the name, or you can order by the name before the country. So it's just, it makes more sense to just order by the name. So you can type in, once you start typing it, it will bring in options for you. Or you can come to the customers table here, drop down, and you see columns, drop down as well. So you can see their names, they use the contact name. You can use the contact name. So let me just start typing back here. Contact. Yeah, so that's going to come up. And I can just use my tab key to enter that. Then I can run that. Okay, alphabetically, meaning from A to Z, that is in ascending order. So if I write order by this thing without putting descending order, it is automatically going to order it alphabetically, that is in ascending order. So the default is ascending, except you want descending, you type in descending. So let me remove this and let's run this. So I said you might want to include a semicolon at the end of every of your statements, just because when you write city sometimes and you don't include this, sometimes you run into errors. So just as a good rule of thumb, anytime you write a SQL query, use a semicolon at the end. So we can also run these two results, right? And they will execute the first one on top, the second one. Let's just run that. So you can see the first one, the results for the first table. Then if you scroll down a bit, you see the results for the second table here. But we're just going to be executing everything bit by bit, so we do not get overwhelmed. Now, if we move to the next one, which is saying get all orders by date. Get all orders by date. So we're still talking about all. So we're selecting all, right? And I think we can skip this I think we can skip. Let's just go through it. Let's go through it. Select all, right? Because I think there are more questions we have there. So I just wanted us to go through another one. Let's get all the orders by their dates. From which table? From our orders table, of course. So we're just going to drag and drop our orders table here. And let's order that by date, since it says get our orders by the date. So let's order that by our date. So that should be let's check the dates. Let's know which date column we're using. Columns for DBO orders can use our order date. So I'm just going to type in order date, or I can drag it in here. Yes, I can drag that in and put my semicolon and then just run only this, execute. So as you can see, everything is by order date here. We have 1996, 07, 04, 1996, 07, 05, everything ordered by the order date in ascending order. Now, if you look at this next question, it says, get the count of all orders made during 1997. This is bringing us to our filter because they're asking for orders that were made during 1997. So, and they're also asking us to do what? To get the count. So this is asking us to get the count of all orders made during 1997. So how many orders did we make in the year 1997? So we already know there's going to be a where clause here to filter out the results in 1997, right? And we know we're getting this from orders table. So let's just start from where we know, then move to where we don't know. So like from orders, so from orders table, let's put that in there, right? And we know we want okay, what did I do? Let's go back to from orders table. From orders, right? Where we want to limit that to orders made during 1997, right? So the year is 1997. So where the order date, people ordered for it in that year. So you're going to bring in your year function, which extracts the year from a particular column. So I want to extract the year from that order date, this order date column. I want to only see 1997. Right? So I can bring my order date here and place it here. And then I'll put that in the parentheses, right? Where the year is what? Equals to which year? 1997. That's fine. Now, what would I have to do? Count of all the orders. So this thing is going to produce me this table first, right? And then it's going to filter that to only 1997 data, right? Then I want it to count how many orders is even here. And that is done by the unique identifier, which is my order ID, right? So I can use count, or rather, I can use the select to count that, which is, I need to select the count of all the orders. So let's write our select statement. Select count of, let's do order ID. Where am I putting this? So this is something you also notice. You notice as, let me remove this so you can see the red lines again. You can see whenever you've not finished your code, or whenever you finish your query and you still keep seeing red lines, there's something wrong somewhere. So you have to make sure you try to look at it and maybe fix it. So now let me put my order ID back there and let's close it. So once I close this bracket, everything is fine now. There is no red lines, so I can run this code and execute this. So I can see that 408 orders. Okay, you see, I didn't this thing now. You see why this says no column name. Doesn't really make sense because what does it stand for? So you need to put an alias as, I can call it as count of all orders, or let me just say as number of orders and I'll run it again, and that should give me number of orders, which is 408. So in a way, let's move on to the next session. Let's just move on to joins. Let's move on to joins for now due to time. So this joins now brings us to let's go back to our slides to explain the types of joins you can deal with before we work on that exercise. So to understand joins properly, you need to understand, you can try to use Venn diagrams. I think Venn diagrams comes in really handy here. They help you understand exactly what joins maybe you need to do. So we use Venn diagrams to try to like conceptualize the joins we want to do. This Venn diagram for here, you can see, shows the employee table connected to the sales order. So in this intersection, you can see sales order that were taken by these employees. Basically, when you have the values here, when this middle portion here is shaded, that is what you call an inner join, because you have results from both of your two tables connected. But when you have just, let's say, just from your employee side, that's where you can get like your left joint and your right joints, which are basically outer joints. And then we also have self joints, where you join a table to itself. Sometimes this is where you start using writing subqueries and views. So let's move back to our SQL query. Now, I just wanted you to know that we have two different joins. We use inner joins, we have inner joins, we have left join, we have right joins. So those are the major two joins you'll be using. And sometimes there are other functions, just as union. Union is going to return the results of both tables, right? Left join will return matching results in both table and results from the left table. What do I mean? Left join return results from employee and sales order that were the same with this middle part, and then it will return only orders in employee, which is the left hand side of the table. What about right join? Right join will return from the opposite, like it's just vice versa, basically. So let's go to SQL Server and try to understand the question and write the queries. So basically, what makes SQL a bit complex sometimes is the fact that it's using word problems. Basically, they're asking you this. You need to try to understand what exactly is being asked, so you know the right queries to write and you generate the right results, because numbers really matter in data analytics. So for this, we'll have to start with this question now. We are asked to create a report for all the orders of 1996 and their customers. So what we're going to do is, let's hold on, all the orders of 1996 and their customers. So we want results that contain orders, and we want results that contains like customers data. But we also want it to just be for orders of 1996. So we've broken it down to what we need, three things, right? Like I said earlier, we want a report containing the customers data. We want a result containing all the orders data. But in this orders data, there's a but there or a filter there for only 1996. So we already know that there's orders now and then there's customers data. We want to get results from both of them. To do that, we need to establish a relationship has been established already. We need to create a join. We need to join both tables together. And this is where your entity diagram comes into place to see the relationship between both tables. So let's go there. Let me show you orders and customers. So let's look at this. Let me zoom it in a bit. So you can see your orders data being connected to your customers data. On which field? On the customer ID, which is the same customer ID over here. So that is the unique ID that connects both tables. So we've seen that. Let's go back here. So we need all the information, right? So let's select all. Or as usual, we always start from the front part to kind of understand what we're doing. But since now we already know what we need to select, we can just do select all. Then from which table? We can start from orders or from customers, whatever you want, right? But we know majorly we want to create a report for all orders, and each orders we want to now see the customers for the order. So let's just start with orders table. So I can just drag this and put this here, right? So I want to say, I always try to, whenever I do joins, alias comes into place. So there's always an as, let's say O for me. Then the next line is now the join. So once you're wondering, what join am I using here? Am I using an inner join? Am I using, I'm just writing join. I don't even write inner. So in SQL, when you write join, you're basically saying inner join. So you need to be specific when you write other joins. You can even be specific when you write inner joins too, right? But once you're writing left join, right join, you have to write left join, right join. But inner join, you can just stick with join. A join by default is an inner join, meaning what? For instance, now I want to get all orders, all from the order table and the related data from the customers table. So that's why I'm using inner join. So I'll join this to what? To my customers table. So I'll just drag my customers and place it there. So whenever you join, you have to join on something. What is that connection? What can make this person and this person join together? That is that identifier that I showed you, which is the customer ID. So let's go back to alias this as C, right? So on what? On the table dot the ID that you can use to connect it. So orders, which is O dot, what can I use? Customer ID comes up already. I'll just hit tab equals to C dot. What can I use? I can use also the customer ID, right? Because I want related, hit tab. Then I can put my semicolon. So this should work for me. But let's run it and then we'll see somewhere. Execute this. Do you see what we get in our order dates? We get 1997, 1998, but they said create a report for all the orders of what? 1996. But let's scroll down. Let's see if we have results, right? We have results, our customer ID, company name. So the join works, but we have not satisfied all the conditions of this question. So we have to filter to only 1996. It's fine. We've already written a filter statement before, so we can do it again. So select from, so we can do a where now, right? Where what? Where this order date is 1996, or the year rather, the year of the order dates. Where's our order date? Let me just scroll down and pick it. Order dates, put it in here. Close the brackets or the parentheses is equals to 1996, right? Then I can execute this. Let's execute that. So once you do this, you notice now that your order dates, you only have what? For 1996. You can scroll down to check your results. So this is why I also say you want to start working with a small table first, where you can basically see all the rows of your data. Like this one, I have 152 rows. I can explore 152 rows and be sure that I'm writing the correct queries. You get. So this will help you as a beginner to learn more and to actually write correct queries first before you practice with more databases and you involve yourself in challenges. So we've answered this one. I want us to try to answer one more question in the next section. Let's go to the next section for now. We're running out of time. Let's just go to the next session. So let's answer the next question, which is on the section for SQL queries for having, using the having expression or the having statement. So now we're asked to do what? We're asked to create a report that shows the total quantity of products from the order details table, ordered. Only show records or products for which the quantity ordered is fewer than 200. Let's try to break this down a bit. They want us to show the total quantity of products, right? But they also want us to only show when the quantity ordered is less than 200, because they said fewer than 200, right? So let's go to our order details table. Let's see if we have this quantity of products that we're going to use. Let's just explore and think what we're going to do about this. So let's go to order details table. Okay, this is it over here. Columns, let's see that. Let's unbox this. Yeah. So we can see we have quantity here. So we can get the total quantity of products. We can do that. We can. But we need to understand first what we're going to use, since we're getting this data from which table? From the order details table. Okay, cool. We can start from there. We're getting our data from where? From our order details table. Let's drag that in. And we're asked to select let's say select the total quantity of products. So if you want to get the total quantity of products, do you think you would be counting each product, or you would be adding them up? Are you going to count, or are you going to sum? What is the total products you have in your shop now in this question? So basically, it's a sum question because you want to get the total quantity of products that you have. So I'm going to just sum that up, and let's bring our quantity here. So this is going to be what? The total quantity of products, total QTY. Now we are asked what? Only show records of products for which the quantity ordered. Only show records for products that have their quantity ordered less than 200. So filter it and only show me products that the order, the amount of quantity that they ordered is less than 200. So I need to use filter. I need to put a where the quantity ordered, right? So this is where I'm getting the quantity ordered is less than 200. So if I bring that, it's less than 200. This is where you notice something that seems to be underlining this. Because like I mentioned earlier, you can't use where with an aggregate function. You have to use having instead. So we have to switch this to having. Okay, maybe it's also showing this because I've not finished my statement, right? So maybe it's also showing that because I've not finished my statement. Right? It's very possible because I didn't close this bracket. Yeah, but let's go back and see. Let me just see if I can prove that point. I changed this back to where to see if it's going to show that. It's going to return an error though. Let me just run this, even though this is not our field results. You see, an aggregate may not appear in the where clause unless it is in a subquery containing the having clause. Basically, just read the first line. An aggregate may not appear in the where clause. So switch that up, change it to having. Then having, right? Then let's see. They said only show records for products which the quantity ordered is fewer than 200. So this makes me see that maybe I want to see the product, right? And see the quantity that total quantity of each product. And I want to see that it's better than just you telling me the total quantity we have. I want to see it by like the product. I know that, okay, product with this ID have this total quantity. Product B with this ID have this total quantity. So let me put a product ID here. So I'm selecting a product ID, right? So I can put that here, product ID, then a comma. Okay, what did I do? Right, then a comma after that. So after each column, you put a comma, right? And there's one thing I've said, whenever you have an aggregate in your select statement, you have another column that is not aggregated, you need to always make sure you use a group by. You need to use a group by, and a group by comes before having. So you have to put a group by here. Group by what? By the one that is not aggregated, which is this control C, then control V. Right. Now this should work. Let's execute this and let's try to get it. So we see for different product ID, we have the total quantity, right? But it might make sense that we want to order this in descending order. I want to see which product is giving us small quantities, right? We want to see the top one first. So obviously we'll have to what? Order. Let's order by what? Order by, we can now use this total quantity. It will work in this case. Then we put descending order, then our semicolon, and then we run this. So you see it's now ranked in descending order of total quantity. Going to see if we have questions first, and if time permits, they can continue. So let me see if I have any questions to say. If you have questions, you can try raise your hand or anything else. Any questions so far? You can try raising your hand. Okay, I think I see a raised hand by let me try to get that, Ben. Let's see if there's any way I can unmute your mic. Or you can type it in the chat box, anyone. Wait. I think I just unmuted your mic. I went back. Allow mic. So Ben, you can type your question in the chat box or you can use the mic. I think you can unmute yourself now. Anyone that's fine by you, type your question in the chat or use the mic to say.
Hello, can you hear me?
Yes, I can hear you now. Loud and clear.
Okay. Good evening, and thank you very much for the class so far. My question is from the question
I'm
you
sorry
just
to cut you short, Ben.
answered.
Can you try can you try speaking a bit louder?
Okay, is it better now?
Yes, it is. Thank you.
Okay. From the question you just answered, there is something I saw the last word at the question, it was something like
Let's
5
go back
rows
there.
in brackets. Okay.
Yeah, let's go back there.
Okay.
5 rows, yes.
So what's the significance of that? Is it to confuse us in the question, or I mean, what role does it play?
Okay. The 5 rows is just it's not to confuse, it's actually the opposite. It's to let you know that, like, when you write, for me, when I do calculations, and data analytics is a very, very tricky questions in a way. It's a very, like, you have to make sure your numbers are correct. You have to check your calculations over and over again that you are doing the calculations well. So sometimes you might even create like a dashboard and you're not even sure of your numbers. You have to check it again and be sure of your numbers before sharing. So in this sense too, this is an exercise I created so that when you people write, if you decide after this exercise, when I share it to you, you write your code, you'll be sure, you see, okay, you're expected to get like 5 rows of data, which is what we have here. 1, 2, 3, 4, 5. So you can be able to know, okay, you got 5 rows of data. At least that will help you a bit to know the results you're getting. But in other cases as well, yeah. So does that answer your question?
Yes, it does. Thank you.
All right, splendid. Yeah, thank you. Is there any other question? Or we move on to answer one more question and then we wrap up the class. If you have any question, you can raise your hands or type it in the chat. Anything. Just 1 minute I'll give, and then I'll go back to continue the exercises. Okay. So I'm just going to continue. Let's continue from, let's take one more and then call. Yeah. Okay, let's take this on. Let's move to the next session. I'm just trying to touch a bit of everything. So for this question now, we're asked what were our total revenues in 1997. What were our total revenue in 1997? So when we think about revenue data, we should see it stored in maybe our sales or order table, but we can see that we do not have that when you check your order details table. Instead, what you have is something that you can use to calculate revenue though. You have your unit price, you have your quantity, and you have your discount. So you can calculate your revenue. So we would have to do that. We'd have to calculate a column for that, right? And when we think about revenue, it's obviously unit price times quantity, right? But then a discount is applied that reduces that value. So multiply, okay, let's just see it. Let me just go, let me do select top 1,000 rows so you see it. So you can see order ID, product ID, the unit price, and the discount, right? So in this let's say $14, 12 quantity were sold and 0 discount on this order. While for this one, we had 15% discount, which makes that 0.15. So I'm just going to just write here, or I'll remove that. It's just like what we want to do probably is to do unit price, multiply by what? Multiply by quantity, right? And then multiply by, since it's in decimal, we can use 1 minus. We can use 1 minus the discount to get the actual revenue, so that we have also excluded like the discount that was given. So this will be our formula to calculate our revenue. This will be what we want to use to calculate revenue. So let's go back to that question. I think I have the questions somewhere here. Can close this. We do not need to save you. Okay. So first off, I want to calculate my total revenue. So let's say select revenue, right? So we're going to bring this unit price. We'll multiply that with what? With our quantity. Multiply that with quantity, right? then we'll also multiply that with discounts, but that should be 1 minus discount. So let me open the bracket. 1 minus discounts. So this will create a table called another table probably, right? But then I don't want just the rows of data. I want to add up everything to give me total revenue. So what I will use will be a sum to wrap around all of this. So it's going to iterate row by row and then sum up everything, right? So I can just sum this as revenue, right? And I'm getting this from which table? From the other details table, which I got their values from. So I've gotten total revenue from the other details table now, but I was asked to get total revenues in 1997, right? So I need to bring in a sort of a filter to make it 90, to apply it, to make it only total orders in 1997, right? So if I check this order details table, I don't seem to have an order date there. So the table was probably broken down, right? So once I go to the orders table, I have the order dates there. So this is where I need to use this order date. But before I can use it, I need to create that relationship, or I need to make that join between order details and between orders table. I need to do this. So let's see if I want to do, let's see, let's try a bit of another, let's try something here. Let's select all the orders here, right? Okay, let's take a step back first. Let me see this. Order details table, I have order ID here, right? Go back. Orders, I have order ID. So this is the relationship, obviously, that we need to use if I want to connect a relationship. So firstly, what I want to do now is I want to take it back down to this orders table. I want to get the only orders, right? That is only the order IDs that was done in the year 1997. I want to first start with that. So let's say I select order ID, Ctrl Z, select order ID from let's see the table from BBO the orders, right? Where am I writing? Where the year of the order date is equals to 1997. So I'll get order IDs from here. So this is going to give me a table on its own that contains just, let's execute this, that contains just order IDs with order date of 1997, if I choose to include that. So it'd be good for me to do an inner join here to just get, if I do an inner join here based on order ID, it's going to get me only 1997 orders. So I could just go directly here to do a join. Instead of joining this with a new table, I'm using the select statement. Let me just include a tab here to create a new table. This is a bit complex. Let me put a tab here, and let me just close this. So this has created a new virtual table that I'm joining with this table. So this virtual table needs to have its own alias. Let me call it as O. Let me just call it as O. Let's call this one as OD. Right. So next thing I need to do is connect the two relationships between this table, which is on OD dot order ID equals to O dot order ID. So see if we have, let's try to execute that and see if we actually on track. So this is where we got exactly 617, right? So this is okay. But this is where this is what we call a subquery. This is a query within another query. So I have a select statement here, and within that same select statement, I have another select statement. So that is what we call a query, a subquery rather, a query within a query, just a subquery. So I wanted us to try to like write that, even though we have run out of time for the class, basically. So what this does, it will select the order ID and filter for year when it's 1997, and it will return only order IDs of orders made in 1997. And I'm joining that with this table so that I can only calculate the revenue for orders made in 1997. I don't know if that is explanatory enough. So I think we've been able to try to get somewhere, achieve something. So what I'm going to do is I will use your mails that I got from the registration form, and I will send the resources to this and this exercise file in case you want to practice. You can always download Microsoft SQL Server as well. If you have any questions, you can drop them now, because about to end the class, right? I just wanted to say, like, in case you want to learn more about this, there are some resources you can use to learn. You can go to the Microsoft Learn platform. There's this very, very good module, Get Started Querying with Transact SQL. And the thing with every module you learn, you see some exercises to answer, and you have like a lab. You have like a lab work that you can do with it. So it gives you that interface to practice within their platform right on there. And I have tried testing it out because someone mentioned that she didn't have access to like a laptop, so she doesn't know how she'll be able to learn. So I tried it on my phone, and I used like a desktop site. So in case you do not have access to a system to start learning, don't let that limit you. You can try it on your phone. Obviously, it's not going to be easy compared to a system, but you can push past that and try it. And maybe when you get chance, you just borrow a system from a friend and you do the rest. So I don't want to take up too much of everyone's time. I'm just going to check if there are no questions more, and then we'll take a break from the class. We'll just end the class. So if there are any questions, raise your hand, put in the chat box, and I think there are no questions for now. So thank you very much for joining. I hope you learned something, because I don't want to take up too much of your time without you actually learning anything. And I hope you continue on your journey of learning SQL. And yeah, you're going to get it, obviously. You'll get there. And thank you very much for joining in. I would like to end the class now. Thank you, guys. You can log off. Thank you.